Now the thermodynamic variables. Thermodynamic variables are macroscopic physical quantities like pressure, volume and temperature etc., which are used to describe the state of the system. The relation between thermodynamic variables is called equation of state. The well-known equation of state, that is for ideal gas, Pv equals to nRT, but for real gas, that is van der Waals equation, P plus A by A n square by V square, V minus into V minus Nb equals to nRT, where n is the number of moles. Thermodynamic variables are of mainly two types: intensive variable and extensive variable. So what is intensive variable? Intensive variable are those variables which does not depend on the matter present in the system and independent of the system size. But in case of extensive variable, they depends on the matter present in the system and is proportional to the system size. The example of intensive variables are temperature, pressure, density etc. But in case of extensive variable, examples are length, mass, volume, area etc. And here is some rules which defines which variable is extensive and which variable are intensive. Rule 1 says that product, ratio and sum of any intensive variable are always intensive. Remember it. If x and y are arbitrary extensive variables, then x plus y is extensive, but x by y and dx by dy are intensive. Here is a very interesting example, that is density. Density equals to mass into volume, mass by volume, but mass and volume both are extensive variable, but their ratio, that is density, is an intensive variable. So remember these rules. And also rule 3 says that if x is an arbitrary intensive variable and y is an arbitrary extensive variable, then x by y and dx by dy will be an extensive variable. And here is another technique to find out which variable is extensive and which variable is intensive. So if we divide a system into two equal parts, those variables which remain same in after and before division of the system are intensive variable, and which variable which are divided in or become half are extensive variable. Here pressure and temperature remain same before and after division, so pressure and temperature are the intensive variable, but volume and mass become half, so volume and mass are the extensive variable. Now here is a table in which I have tabulated all the intensive and extensive variables. So remember this. In case of intensive variable, pressure, temperature, density, surface tension, boiling point, molar specific heat, molar entropy, molar enthalpy, dielectric constant, electromotive force, that is EMF, intensity of magnetic field, molarity, molality, pH scale, pH etc., all are intensive variable. And extensive, in case of extensive variable, mass, length, area, volume, energy, internal energy, number of moles, heat capacity, entropy, charge, magnetization, polarization, entropy, Gibbs free energy, all are extensive variables. So remember, all the energy terms present in the thermodynamics are extensive variable, and all the quantities or variables measured per unit volume or per unit mass are intensive variables.